but I would like to welcome the audience to our first invited lecture. And my name is Ingo Stadler from TH Köln in Germany. I have the pleasure to introduce our invited lecture. I myself, I'm a bit disappointed that we are meeting here online and not in Sao Paulo itself. I love Brazil. I'm so often there because I organize our university collaborations with Brazil. Most often I'm in the Northeast in Fortaleza, but also regularly in Rio de Janeiro, or recently we started with the hydrogen boom, also cooperation with University of Santa Catarina. Unfortunately, I never had been at USP so far.
We may invite you.
Yeah. I have the pleasure to introduce Professor Paulo Eduardo Artaxo Netto. He is graduated in physics by Universidade São Paulo, USP, in 1977. He holds a master in nuclear physics and a PhD in atmospheric physics, all two by USP. He worked for NASA in the United States, the universities of Antwerp in Belgium, Lund, Sweden, Harvard, the United States. Currently, he is professor at the Department of Applied Physics at the Institute of Physics at USP. He works with physics applied to environmental problems, working mainly on issues of global climate change, environment in the Amazon, physics of atmospheric aerosols, urban air pollution, and other topics. He is member of the Brazilian Academy of Science and the World Academy of Science. He has published hundreds of scientific papers and presented more than 1,000 papers at international conferences. He is also a member of the Intergovernmental Panel on Climate Change, IPCC, and of a lot of other international scientific panels. I don't want to mention all of them. So now I would like that we welcome Paulo Artaxo with his lecture, Climate Change and the Challenge of Regional and Global Sustainability. The screen is yours.
Thank you very much, Ingo. Hello to everybody. Good morning, good afternoon, depending on where you are. So I will start sharing my screen. Okay. So basically the idea is to discuss one of the major issues for humanity over the next decades. That is how to fight climate change and at the same time have a minimum of sustainability, not just on the climate, but also on the social and economic issue, as we're gonna discuss briefly. So basically, first we take a look on the recent past. So let's take a look a little bit of history. It's always important to remember that the Stockholm United Nations Conference on the Human Environment, that was the very first global conference dealing with the sustainability for our society, happened already 50 years ago. That was in 1972. The Rio 92 conference was already 30 years ago. The Rio plus 20 was 10 years ago. And then we had the 26th Conference of Parties from the climate agreement in 2021. On the right, you see, let me get my laser point here, you see basically the evolution of temperature since the start of the Industrial Revolution until today. So you can see very easily that basically what we see is that any of the COPs had no impact or no effect on reducing emission, or at least minimally mitigate the temperature increase. So basically we have now a planet that is 1.1 degrees hotter than before the Industrial Revolution, and some continental regions like Northeast Brazil or Amazonia is already 2.2 to 2.3 degrees higher temperature, and parts of the Arctic are already experiencing more than 2.5 degrees in increased temperature. So basically, this is what we call the climate emergence that we all heard about over the last few years. The first thing that is also important to notice is that climate change science is very solid. On this slide, it's just a few of the recent reports on climate change, not just from the IPCC, but also from the UNEP, from the Biodiversity Commission, from everything, from food production, and so on. So basically, you see that recently the climate change science per se is very, very solid with a lot of work from the scientific community. And then the last IPCC report are really relevant because of the very clear message that science is telling to our societies and governments. The phrases like this: recent changes in the climate are widespread, rapid, and intensified, and unprecedented in thousands of years. Look that, pay attention that our planet has 4.5 billion years of age, and humanity, Homo sapiens, appeared in our planet only in the last 200,000 years. And climate change, it's really intensified just 50 or 60 years ago. So this is a very, very, very recent phenomena that is changing the planet, that is unprecedented in thousands of years. And then IPCC sent a very clear message. Unless there are immediate, rapid, and large-scale reductions in greenhouse gas emissions, limiting warming to 1.5 degrees will be impossible. So basically, you're going to learn over this presentation that actually our emission patterns today are bringing us to an average increase in temperature of 3.2 degrees in average, that in continental areas will increase the average temperature by about 4 to 4.5 degrees. This is where we're bringing humanity and the climate of the planet to an unprecedented level. And this is basically caused by emissions of greenhouse gases. So this is the global net anthropogenic emissions. So basically, we are emitting about 60 billion tons of greenhouse gases every single year to the atmosphere. And this, besides 50 years that science put clear message to governments and the society, the emissions are still increasing by 2 to 4% a year over the last 10 years. So basically, all Paris Agreement, all the Conference of Parties have an absolutely negligible effect so far for the reductions in emissions. And this increasing of emissions are bringing important changes in the climate. So on the plot here on the left is the temperature record of the last 2,000 years. So basically you see that the temperature was very, very stable over the last, let's say, 1,000, 1,500 years. And then recently we'll see this strong and very fast and rapid increase in temperature that is not, that had no history for at least 2,000 years. And actually, when you get the period of the climate system that were as hot as today, was at least 100,000 years. So this gives a dimension of how serious is the climate emergence we are getting into right now. And this small film show the land temperature anomaly distribution from the 60 up to today, where you see that in 60 and 70, the average temperature was more or less close to zero, and then it starts to shift quickly to the right to a hotter planet until we could have in 2020 an average increase in the land ecosystems of about 1.6 degrees. So basically where humanity do most of his activities, actually you are experiencing an increasing above what the target for the Paris Agreement. And it's also important to see the increase in climate extremes here. You see that the fraction of the time where you have temperature larger than 2 degrees above the average or 4 degrees above the average have increased by more than 80%. And one of the results is, of course, the climate extreme events we are having with the heat wave over the United States, over Europe, and over Asia that we are experiencing over the last 3-4 weeks. And this is not news, new issues. For instance, in South America, the temperature anomaly shows that a significant part of Brazil and also Peru, north of Argentina, have already increased in terms of temperature more than 2.3 degrees, and shows that the planet is heating up very, very fast. And on the map on the right, you see the precipitation anomaly, showing that actually Brazil and South America is becoming much drier over the northern part of South America and a little bit wetter in the southern part of Brazil and northern part of Chile. So basically what we are seeing is very important changes in precipitation pattern as well as in temperature. And then humanity is very interested in to know where we are going to. Basically, what the climate modeling can tell us about the future of the temperature in our planet. So for that, you need to understand the relationship between emissions, concentrations, change. This brings concentrations, changes in concentration of greenhouse gases. This changes the radiative forcing of our planet. That is the fraction of the energy that the planet uses to keep life on Earth. And then this brings warming, and this brings the impacts we are observing. So basically, human activities directly are responsible for the changes in the atmospheric composition. This changes the energy balance of the planet, and then we have important impacts. And then to predict the future climate, IPCC have designed 5 different scenarios. One of them is the scenario as we are going to right now, keeping it emissions as we have right now. As I mentioned, we are emitting about 60 billion tons of greenhouse gases to the atmosphere. And then there are 2 different scenarios with the loose implementation of the Paris Agreement and 2 very aggressive scenarios of reducing emission and stabilizing the climate. For these 5 scenarios, we enter these in large supercomputers that try to model the complex climate in our planet that includes our society activities. And then the results are shown in this plot. Basically, if you don't do anything in terms of a reduction in temperature, we can bring the planet to a 4.4 degrees in heating in average. If you implement the Paris Agreement, first, in a very loose way, we can increase the temperature at 3.6 degrees or 2.8 degrees. And if you do a very strong actions immediately, as I'm going to discuss later in the presentation, we can limit the temperature to 1.8 degrees or 1.3 degrees. So basically, you see that these are the scenarios that the governments and our society are dealing with. Which is the future of climate that we want? Do we want to increase the temperature by 4.5 degrees in our planet? Or, and this will bring a lot of consequences like destruction of ecosystem, disruption of the food system, and so on. Or we want to go for minimum of the greenhouse gas emissions and then keep the climate with the minimum perturbation from human activities. These are the questions we have to deal with right now. And then, but more important than the average temperature for the whole planet that includes the ocean, it is important to analyze the geographical distribution of this increase in temperature. If you allow the planet to heat up by 4 degrees, basically Brazil and South America, we have an average increasing between 4.5 to 5 degrees. The Arctic, Canada, and Russia can have an increase in temperature of between 6.5 to 7 degrees with very large impacts on the ecosystems. But in addition to the increase in temperature, we are also changing the precipitation pattern, where and how much rains in every piece, in every part of our planet. So you see that, for instance, if you allow the temperature to go to 4 degrees, we have South America, North South America, including Amazonia, a much drier region, as well as Southern Europe and Central America and South Africa. So basically, this is a process that is already happening, is not a future projection, because we are already observing these changes in precipitation. The changes in precipitation bring important changes in soil humidity that is critical for agriculture. So if you allow the planet to heat up by 4 degrees, looking for the soil humidity amount in South America, in Central America, and Central United States, it's important to note that, Nevada and California is already being observed much lower precipitation than, let's say, 30, 40 years ago. But also South Africa and the Mediterranean, Europe, north of Africa, will also observe a very significant reduction in soil humidity. And this is critical for food production. For example, here you have a more detailed map of the change in soil humidity. You see that no question about, we will have a severe change in the geopolitical issues with the capacity of producing food very much compromised by climate change. And then this is not new. Brazil knows this quite a long time. This is a report from Embrapa, the Brazilian Agro Industry Research Institute. This is a report from 2019. So you see that, let's say, in the recent past, the regions with high or very high water deficit was limited to the northeast part of Brazil. But now, this is being extended to Goiás, Mato Grosso, Tocantins states, and this is getting more intense this decade, and next decade we will see an important reduction in precipitation in the areas where agricultural production is very intense in the central part of Brazil. So this has important implication for what kind of economic development Brazil and other countries plan to have over the next decades. And this is also not new from the World Economic Forum. So basically, the World Economic Forum Global Risk Analysis from 2020 shows that the risk in the impacts of food production in a 3 degrees hotter planet is a reduction in the yield, in the productivity of food for South America, for most of Africa, Southeast Asia, and India. So you see that the tropical countries certainly will suffer most from the increase in temperature and decrease in precipitation, while countries like in Scandinavia, Russia, and Canada will have a possible increase in productivity in their agricultural systems. But basically, you see that most of the United States, Central America, and South America will suffer significantly from climate change. And then there is the issue that climate change is already affecting weather and climate extremes all over the world. So it's very, very significant changes in climate extremes identified by IPCC. So basically you see that last year we had 52 Celsius in California, we have 48 degrees in Canada, in Vancouver, and at the same time, we have the largest precipitation in the last century in Germany. We see drought in central Brazil, the largest flooding in Amazonia in 119 years. So basically, it's very, very clear that climate change is bringing more intense and more frequent climate extreme events. We are seeing this year, we are still going on with strong heat waving. For the first time, it's important to note this detail. We had previously heat waves in Europe, in United States, in Asia, but now we have a heat wave that simultaneously gets the 3 continents. And a temperature of 44, 43 degrees in Spain, in Portugal, in California. And then this is bringing a lot of fiery danger forecast for Europe, for California. You see Yosemite being half burned so far. So basically, this brings a lot of socioeconomic issues, including the loss of lives. And how climate extremes will change in the future. So IPCC addressed this issue, put the simulations included the simulations in the climate. So basically, one single event that happens every 50 years before global warming took over in a 4 degrees Celsius world, this event will be 39 times more frequent than, let's say, 100 years ago. So basically, this will happen, extreme events will happen almost every year if you allow the climate to go 4 degrees. And they will be 5 times more intense. So basically, this is a very clear message from science to this society about the climate extremes. Another important impact from climate change is the change in sea level. So basically, sea level is rising significantly over the last, let's say, 50 years. And the forecast for IPCC is that at current emissions, we could see increase in sea level, in average sea level rise by 1 meter if all high probability events are included, and if the low likelihood events are included, we can have an increase in sea level by 1.7 meters. So this is a huge change for all coastal areas, for all the planet. And of course, this is an average sea level rise. If you see that some parts of the world will have a much more significant increase in sea level, so this will impact millions or billions of people worldwide. But in addition to that, IPCC have also made simulations on how could be the global sea level in 2300. So basically 300 years from now. The important point is why IPCC have done that? By a simple reason. If you melt 1 cubic kilometer of ice from Greenland and this water goes to the ocean, increasing sea level, there is no physical process that could revert this process. I mean, this is an irreversible change. And if we continue emissions of greenhouse gases, the global sea level rise could reach 15 meters by 2300, according to the simulations from IPCC. So again, it's a very, very clear message for the society to reduce immediately greenhouse gas emissions, as we're going to see in the end. And another important message is that the proportion of CO2 emissions that are being taken by the land ecosystem and the ocean will be reduced significantly with the higher cumulative CO2 emissions. So basically right now, the atmosphere and the ocean are absorbing 70% of our emissions, and this could be reduced to 40% if we will continue emitting greenhouse gases as we're doing now. What this means? We will accelerate global warming very significantly. And then just a little bit discuss the relevance of Amazonia. That is an important tropical forest, and it's important to understand that Amazonia impacts very significantly global climate through deforestation and greenhouse gas emissions. But on the other side, climate change also impacts Amazonia very significant to forest degradation. That is a process that is already going on, so making Amazonia a source of carbon to the global atmosphere. This has been simulated by the climate models, and what happens is that when we analyze the carbon uptake, the photosynthetic response from ecosystem to climate warming, you see that Amazonia will become a net source of CO2 to the global atmosphere at a rate that could reach 1 kilogram of carbon for every square meter for every degree Celsius that will allow the climate to heat up. And this is important because Amazonia contains 120 gigatons of carbon in the ecosystem, and this is equivalent to about 10 years of fossil fuel emissions. That with the progressing of climate change, this carbon that is stored on the ecosystem right now and have been there for millions of years could start migrating to the atmosphere, aggravating the climate system. This is what we'll call the tipping point from the Amazon. And in addition to that, we have a very high deforestation rate in Amazonia, even right now, after Paris Agreement, after everything. So you see that Brazil shows that it's possible to reduce emissions from deforestation. Brazil have done it already. It is the cheapest, fastest, and easier way to reduce emissions is reducing tropical forest deforestation. But unfortunately, because of the actions of bad and irresponsible governments, what we are seeing is an increase in deforestation in Amazonia over the last 5 to 6 years. So basically, we have to zero this deforestation by 2028. So we are observing an increase by 21% for 1 single year alone. And the Global Carbon Project sending a clear message that achieving net zero by 2050 depending critically on the Earth's natural carbon sinks. So basically, we have to preserve the natural carbon sinks in the boreal forest, in the temperate forest, in the tropical forest, wetlands, and so on. So basically, science gives you all the ingredients of how to avoid the aggravation of the climate emergency. So science have done his job. So basically now, the task is with our government, and which have been the actions of the government. So we can see the document from the COP26, the Glasgow Climate Pact, as we will call it, basically see a tremendous distance between science and the geopolitical interest, especially from the developed world. IPCC says clearly we needed to reduce emissions by 45% until 2030. That is only 80 years from now, but you are in the wrong direction. We are increasing emissions with all these warnings that science has made over the last 50 years. We are going to an average increase so far today with all the implementation from the Paris Agreement to about 3.2 Celsius instead of 1.5 Celsius, that is the target for the Paris Agreement. So basically, we saw in Glasgow an agreement to reduce methane emissions by 30% by 2030. So basically, there are some advancements in papers and in agreements, but very few results so far in, let's say, concrete terms. So basically, the net zero targets, net zero emission targets for most of the developed countries are for 2040, 2050. Some countries has a target for 2035, but ideally, this should be 2030. But basically, India has the target to become net zero only in 2070, China in 2060, Brazil in 2050. So we are very far from what science says that is absolutely necessary to stabilize the climate. And basically, there is an important difference in developed versus developing world, because in COP26, the poor countries of the world asked for help, financial help from the developed world to reduce their emissions that will profit everybody. So basically, they were claiming about 100 billion per year of help for the poor countries to adapt and reduce emissions. And what was the answer from the developed world? No, we will not provide these funds for the developing countries to reduce their emissions. We have to negotiate this at the next COP. In a scenario like this, possibly we will see much stronger heat waves as we are observing right now in Europe and United States and in the developing world. So basically, we see clearly a need to change the socio-economic system and the governance of the climate change and global problems. I'm just going to finish my presentation. I think IPCC sends a lot also on positive message on climate change. IPCC says clearly there are options available now in every sector that can at least halve the emissions by 2030. So the message is very clear. We have all the technology in all sectors to reduce emission by 50% in 2030. The message could not be more clear, And this includes the energy sector, the land use sector, industry, urban, buildings, transportation systems, and also on the service economic sector. So we don't need anything else than implementing what science tells what we have to do. And this is basically due to the fact that renewable energies prices has fallen below the burning of fossil fuel. We'll see the price from photovoltaics coming down from $600 per megawatt hour to about $70 per megawatt hour. So basically, we see that it's cheaper to produce electricity from photovoltaics than burning fossil fuel, especially now with the increase in prices in the oil prices. The same with the wind onshore and offshore wind generation. The prices are much, much lower than they were 10 or 20 years ago. And then there are options available to reduce emissions in all economic sectors, in special the energy sector and the changes in what we call AFOLU, that is afforestation, florestation, and other land uses. So you see that we can significantly contribute to net emission reduction from these two sectors that could help a lot to stabilize the increase in temperature at the maximum 2 degrees. And in particular, the forest sector has the very low cost to implement this change, and wind and solar energy, the costs are lower than burning fossil fuel. So you see, it's possible. The message could not be more clear. And then what we have to discuss in terms of society and conference like yours, it's important to make this discussion widely, is that we are here, 2022, when IPCC released his 3 reports. And the question is, are you going in the future to a world where we have a lot of vulnerability, high poverty, we will have a very low resilience to climate change, or we will adapt and stabilize the increase in temperature in 1.5 and 2 degrees. We keep the ecosystem healthy, the equity and justice in the very best point. So basically, we have to choose a pathway from now to the future. The pathway that the economic sector have chosen is this red one, very clearly, with emissions of about 60 gigatons of CO2 equivalent to the atmosphere every year. But certainly the interest of most of the population is actually to build up a sustainable world, because that is the only way we could guarantee a minimum of well-being for our society. And it's important also to analyze who actually is responsible for the emissions of greenhouse gases. What we see is that the 10% rich of the population emits 49% of the total greenhouse gases. The most vulnerable and the 50% poor of the population emits only 10%. So it's a clear message that our level of consumption, especially in the developed world, is completely unsustainable. And the problem is they are responsible for most of the emissions, but who will suffer most from the increase in temperature is not an American that lives in Texas in a 400 square meter home and have 3 cars in his garage, but actually is a poor guy in Bangladesh, in India, or in the favelas here in São Paulo or Rio de Janeiro. So there is an intrinsic link with the inequality that certainly is a very important part of this equation. So basically then for science, the question is how to build a safe and fair space for humanity. So how to combine the basic needs of the population, water, food, health, gender equality, social equity, energy, jobs, and so on, to the limits of our planet in terms of use of water, preserving biodiversity, and so on. So science, an interdisciplinary science in particular, have to build up the bridge, taking care of the safe and fair space for humanity. So this is a huge task that we scientists have to fulfill over the next few decades. And a very good guidance for science and also for governments are the United Nations 17 Sustainable Development Goals that put a pathway on how we are going to deal to build up a sustainable society with no poverty, with zero hunger, with good health and well-being for everybody, and so on. Climate change is the SDG 13, is the climate actions for a sustainable planet, but many others SDGs actually depend critically from the climate. So basically, this is a huge task that you have to change our economic system completely, actually, to fulfill and build up a sustainable society. So basically, it's very clear that the climatic and environmental issues will be increasing in relevance for our economic development and our social impacts, including jobs and socioeconomic inequalities. And I leave you with a possible picture of the new climate of the planet that you have to avoid as much as possible, but we are not being able to track, to guide the societies and governments to a sustainable society as is absolutely necessary. So basically, I stop sharing my screen right now, and I will be very happy to answer any questions you could have. Thank you for the attention.
Thank you very much for your interesting presentation, Paulo. You are free to ask questions. I don't see any question in the questions and answers frame, and also not in the chat. So I will allow to ask my first question. When you, as a Brazilian, look at the moment to Europe, Professor Nevenduich just had presented the current war in Ukraine and the loss of natural gas in Western Europe, and how we are looking, where do we get gas, but we are not really looking for other alternatives. What do you think about when you see that in your horror scenarios, how we are at the moment looking for natural gas alternatives?
Yeah, that's a very good point. You know, of course, what we are seeing is how close the geopolitical issues are associated with the climate change issues and build up a sustainable society. The war in Ukraine is a clear example, you know, and then of course, one country is doing, let's say, how can I say, because of the natural gas issue to power the European economy is getting in a critical state. So this is just a reflection that, let's say, 20 or 30 years, Europe could have going to a sustainable energy pathway even in a stronger way than they have done. So it was a mistake. I think many persons recognize it today. It was a mistake because we have alternatives to the natural gas from Russia. But of course, you cannot change that in 1 year, 2 years, or even 5 years. This takes time, but the time has passed 5-10 years ago to build up a Europe that is more independent from the energy point of view. And this mistake is costing Europe a lot today. So this requires governments to have a long-term thinking.
In the Q&A session, we have now contributions, but just congratulations for your talk, not a question. But I see that Neven Dujic is raising his hand.
Thank you very much for a very interesting lecture. My question is, I'm more of an engineer and working in energy planning, and I see that energy transition is now fully feasible. So techno-economically, we could actually do it quite quickly, the mitigation, but we are not doing it, or it's going very slowly. What I see that the barriers are mostly socioeconomic, because there are vested interests who are investing quite a lot of funds into slowing down transition. Can we find a way how to include those vested interests in the transition process? We are thinking about offshore wind as a solution, because that is something that oil companies can work on, but it's going also very slowly.
Yeah, very good point. Let's give you one example. I think there is no other country who have a renewable potential for energy as Brazil. We have plenty of solar availability, especially the northeast part. We have plenty of winds with the 5,000 kilometers of coastal area. And do you know how much Brazil have a generation in terms of renewables, in terms of solar and windy? 4%. So basically, you see that is wrong decisions by governments, not just in Brazil, of course, but this does not happen by chance. Of course, the lobby of fossil fuel industry to all governments, including Brazil, are much stronger than the interest of the population per se. So basically, actually, it's big money is funding from the financial sectors that is putting billions and billions, if not trillions of dollars in the fossil fuel industry that is delaying the process for this transition. And we are paying huge amount of socioeconomic cost for the general population because of the lobbying of the fossil fuel industry to all governments. This is not particular for the United States or whatever, UK and so on, or Brazil. So we have to change this picture very, very fast with a lot of political pressure from the population itself. That is the only way I see we can change this pathway.
Then we have, you want to re-answer?
Just thank you.
Okay, then we have now a question from Rafael Belém Lavrador, and he is asking, given the correlation you showed between development and emissions, what pathways are possible to reduce inequality while reducing global emissions?
Rafael, very good question. So basically, we have all the possibilities to reduce emissions, and at the same time, reducing inequalities. Of course, I finished my presentation with the Sustainable Development Goals because, you know, climate change is not the only problem we are facing right now. Inequality, especially between developed and developing countries, are increasing very significantly, and this bringing stability for the global planet. And then you can imagine, you saw the scenarios for increase in temperature. Can you imagine the amount of immigration from Central America to the United States or from Africa to Europe in the next 20, 30 or 40 years? Will be absolutely 10 times or 100 times more intense than today. And this will certainly bring very important instability in the political system. So basically, we have to invest heavily on poor countries for the population to stay there, giving them development alternatives and at the same time reducing global emissions. So basically, this is the only way we could construct a more stable society, a more efficient society, and a more sustainable society.
Thank you. At the moment, I do not see more questions, and so I will ask another one. What I'm always missing in the suggestions is that I'm an engineer, but I think not everything is a technical solution. What about the sufficiency? For example, the young generation, including myself, is in Europe used that all rooms are always warm all the winter. And I remember the discussions with my grandparents and also my young parents. Yeah. They said, in winter, we only had the kitchen that was heated and the rest of the house was cold. We just couldn't afford the fuel. Don't you think that we also need maybe to rethink our waste that we are used in the young generation?
No, the change, yeah, for sure. We needed to have a strong comportamental change. For instance, we have about 2.5 billion cars in the world. Do you need that high amount of cars in the world? My city, São Paulo, has 7.7 million cars on the streets. Is this sustainable? No way. So basically, we have to change transportation, we have to change edification, we have to change a lot of things. And we know how to do it, and we are not already know what to do. So basically, what we need is public policies that could implement this change as quickly as possible. We don't have 30 or 50 years to change our consumption levels. And then that is the only way to build up a more sustainable society in terms of consumption. We have to change transportation, we have to change edification, heating, cooling, and so on. Otherwise, we will not be able to have a stable climate in the very near future.
Thank you. Now we have several questions. So when we come to the end, the one is from Sheer, one of the members of the ISC. It's a long question, so I think I need to read it. I haven't read it so far. How can the climate neutrality target be best combined with land degradation neutrality target in Brazil? Can deforestation be shifted to preserve and increase existing carbon sinks while moving to more sustainable energy, water, and environment systems? It is estimated that deforestation for pasture and soybean has lengthened the dry season locally by about 7 days more since 1980. Yeah. That is extra at a local level. Why intensifying climate change, the loss of carbon in the Amazon with the combined effect of both land use change and climate change can be about 40% in a 4 degrees Celsius world, but limited to 8% when the 1.5 degree temperature global goal is kept. Reductions in river discharge would be also 27 to 53% in different river basins in Brazil, including Rio Tabajos, under different scenarios. All of this with key risks of food, water, health, cities and infrastructure, ecosystems, and livelihoods.
Perfect. I agree. I sign below all these issues. And then I have not explored adequately, as Sir is mentioned, is that Amazonia is already starting to lose carbon, according to several papers, according to in situ measurements from towers in the forest, from satellite measurements that shows that Amazonia was absorbing a very large amount of carbon through photosynthesis from the atmosphere and is becoming carbon neutral, and the eastern part of Amazonia is becoming a carbon source to the global atmosphere. So this is extremely relevant because Amazonia, together with the methane emissions from the permafrost from boreal forests, are the two largest tipping points from the climate system. If you don't stop this process right now, decreasing the increase in temperature and the changes in precipitation, this will be impossible to stop the process of forest degradation, as the question mentioned. And that is very, very clear. And we are really emphasizing the need not only to reduce deforestation, that you have to do it immediately, as quickly as possible, because it's by far the cheapest, fastest, and easier way to reduce emission. But if we zero deforestation and the developed countries and the rest of the world continues to emit 40 to 50 gigatons of carbon per year, so the Amazon will have no chance of surviving in the near future, and then we could have an aggravation of climate change very quickly and very seriously.
And then we have anonymous participant, and he is asking, for your presentation, we can infer that the great responsibles are the rich and developed countries. How can they make changes in their economy and society so that underdeveloped and poor countries can develop? It seems that Brazil has more clean energy, and yet very occasionally we see people, many times even celebrities, blaming Brazil from developing, using and advancing in our land. Many times for me it seems more exploitation and submissions for us, and they living as they want by them. What do you think?
I think that is not the issue of blaming one or the other, developed or Brazil or the holding of tropical forests. Basically, we will need the help of joint work of everybody, developed and developing countries. Without this, I don't see any possibility for us to get out of this climate crisis. And it's important to know that the issues of the developed and developing countries are intrinsically linked. I try to show this in my presentation. It's very artificial to separate both issues. We need governance actually to deal in a quite equilibrated way the reduction of fossil fuel emissions from developed countries, reduction of deforestation in tropical countries, Brazil, Indonesia, Congo, and so on, as well as to change the level of global consumption for everybody, for the 7.7 billion people. The level of consumption we have right now is completely unsustainable, even in the very short term. And this has to change. And this will change the whole economy that is based on infinite economic growth forever. And this is impossible to have in a planet with the limited natural resources. So now we are facing a very clear deadlock, let's say, so we have to act very quickly, and the scientific community have to go ahead and warn as much as possible the societies and governments where we are going to.
Paulo, we have two very short questions to finish the session. And the first one is coming from Maria Amelia, and she is asking, do you think electric cars would be a solution for Brazil?
Electric cars will be a solution for everybody. Of course, the future of individual transportation will be electric. It will not be, the cars we have that are based in 100 years old technology. The issue is that in my city in São Paulo, if you change 7.7 million cars powered by gasoline or ethanol by electric car, you will still have a tremendous problem. We have to invest in transportation for mass transportation systems. We have to change the whole philosophy of individual transportation in cities with the shared cars, much smaller cars. We don't need to transport 2.5 tons of steel and batteries to transport an 80 kilograms person. So this is stupid. And that is exactly what we are doing right now, and these have to change.
And then I think it's an excellent last question from Beatrice. And she's asking, in your experience point of view, will humankind be able to stop or reduce climate change? Are you optimistic?
The clear answer is yes. We will win this fight. And why I think that? We do not have any other alternative. Do you have a plan B other than not change the climate to a dangerous level? No. So basically, we will win this crisis, but it will not be easy. There will be losers, there will be winners. That this will change the global geopolitics. We need the governance, global governance, to deal with things like that, because the United Nations was not designed to do that. So we have tremendous challenges to go ahead. But the final results, in my opinion, will be a society that fulfills the 17 Sustainable Development Goals, because we do not have a plan B. We don't have a planet B where we could move everybody out from planet Earth. So basically, we have to solve this issue as quickly as possible here, and in my opinion, we will do it.
That is great that you're so optimistic after your horrible slides you have presented. I think it's a good point to stop here. I would like to thank you once more, Paulo. And I'm not sure whether Rita wants to take over to finish the day.
Thank you, Ingo. Nevin, do you like to finish the session, or may I do this?
Please finish, yes.
Okay. Thank you, everybody. Thank you, Paulo, for your very interesting presentation. Was very alarming, but it was fine for us. I think we need this shake to take some actions. Then it was very appropriate. Thank you very much. And thank you very much, everyone, all the attendees for this first day. And I hope to see all of you tomorrow and enjoy the conference, see the presentations in the site, in the website, for the others participants, and see you, all of you, tomorrow. Thank you, Ingo. Thank you, Nevin, for all.
Thank you. Bye-bye.
Bye-bye.